The James Webb Space Telescope has done it again. It's uncovered a galaxy so ancient, it's forcing us to rethink what we thought we knew about the early universe. And to understand just how big this is, we need to go back, not to the Big Bang, but to the year 2022. Before 2022, the most distant galaxy ever observed was GNZ11, discovered by the Hubble Space Telescope. With its 2.4-meter mirror, Hubble had already taken us further than we ever imagined, revealing galaxies from the deep past. But it had its limits. There was only so far it could see. Then came Webb, a new kind of eye on the universe. Its 6.5-meter mirror, designed specifically to detect infrared light, made it the perfect tool to hunt for the universe's earliest galaxies. Why infrared? Because as the universe expands, the light from ancient galaxies stretches, and what once was visible becomes infrared. From the moment it started observing, Webb didn't just pick up where Hubble left off, it rewrote the record books. Among its first major discoveries was a galaxy called Jade's GS Z13-0. And it wasn't just far, it was unbelievably far. This galaxy had a redshift of 14.32, making it the oldest confirmed galaxy we've ever seen. So what does redshift really mean? Think of it as a cosmic timestamp. The more stretched the light, the longer it's been traveling. A higher redshift means we're looking further back, closer to the very beginning. Then came MMZ14, a galaxy with a redshift of 14.44. That pushed our gaze even deeper into the cosmic past, but it wasn't just the redshift that left astronomers speechless. It was what the galaxy actually looked like. This galaxy is tiny, just around 500 light-years across. To put that in perspective, the Milky Way stretches over 100,000 light-years. But what MMZ14 lacks in size, it makes up for in brilliance. It's incredibly bright. At this point in the universe's timeline, galaxies were supposed to be faint, hard to spot. But not this one. MMZ14 is bursting with newborn stars, a chaotic stellar nursery, firing on all cylinders in the very first chapters of cosmic history. But then, scientists noticed something missing. There was no sign of a supermassive black hole, and that was weird. Most galaxies undergoing intense star formation, like this one, tend to have a supermassive black hole anchoring their core. These black holes are thought to play a crucial role in shaping galaxies, regulating star formation, influencing structure, driving growth, but MMZ14, nothing, just stars. And the mystery deepened. When astronomers used JWST's spectrograph to analyze the galaxy's light, they discovered something else. Its light was unusually rich in nitrogen, far more than expected. This chemical signature closely resembles what we find in some of the oldest star clusters orbiting our own galaxy. It suggests that MMZ14 formed stars in incredibly dense environments, something we didn't think happened this early in the universe. That's the surprising part. Galaxies from this era should be chemically simple, mostly hydrogen and helium. But MMZ14 tells a different story. Multiple generations of stars had already come and gone, which means galaxy evolution may have begun much earlier than we ever imagined. And that leads us to a bigger question. How many more galaxies like MMZ14 are out there? Before JWST, we thought galaxies this early were extremely rare. Now, they're showing up all over the place. These ancient bright galaxies, often called little red dots, are appearing throughout JWST's deep surveys. MMZ14 might be the record holder for now, but that title might not last long. And that's what makes this moment so thrilling. The more we look, the more we find. And with every discovery, we chip away at what we thought was certain. If galaxies like MMZ14 were more common, more chemically advanced, and forming stars faster than expected, what else are we missing? Does this challenge our entire model of the universe? In one word, yes. Current theories say galaxies in the early universe should be rare, slow-growing, and simple. MMZ14 is none of those things. It's fast, bright, and chemically complex. It doesn't mean our models are wrong, it means they're incomplete. MMZ14 is a clue, a hint that the early universe may have been far more active than we ever imagined. And this is just the beginning. Later this decade, the Nancy Grace Roman Space Telescope will launch, joining JWST in its search. But Roman will look at much larger areas of the sky in extraordinary detail. Together, they might uncover hundreds, maybe thousands, of galaxies like MMZ14, each one a time capsule, frozen in light, from a time we're only beginning to understand. For now, MMZ14 stands as a milestone, a flicker from a universe still finding its footing. But the more we explore, the more the cosmos surprises us. Some scientists poring over this new data have even proposed something radical: that our entire universe might exist inside a black hole. A new study just revealed something strange. Most galaxies across the observable universe seem to be spinning in the same direction. Let that sink in. By analyzing the shape of spiral arms in thousands of galaxies, astronomers traced their rotation patterns. And what they found defied expectations. In a truly random universe, we should see a roughly equal number of galaxies spinning clockwise and counterclockwise. But we don't. This unexpected imbalance suggests that something much bigger might be influencing the entire cosmos. And according to some scientists, it could mean we're living inside a black hole. To understand this idea, we need to talk about black holes. When enough matter collapses under gravity, it forms a black hole, a region with an event horizon, a boundary beyond which nothing can escape. Not even light. Anything crossing that line is lost forever, at least to us on the outside. But what happens inside that event horizon? That part is still a mystery. And that's where a bold theory comes in: black hole cosmology, also known as Schwarzschild cosmology. This theory proposes something radical: that our entire universe might be the inside of a black hole formed in a larger parent universe. Now think about the Big Bang. In the standard model, it's the moment the universe began, from a singularity, an infinitely dense point. But that's also exactly what we think lies at the center of a black hole. So what if the Big Bang wasn't an explosion in empty space, but instead the moment matter collapsed into a black hole, forming a new universe inside? That would mean every black hole in our universe could be a gateway, a portal, to another universe. And it might explain something else: why the laws of physics in our universe seem so finely tuned for life. If only black holes that produce stable, life-permitting universes survive, then the universes we observe, unlike ours, would naturally seem fine-tuned. This theory also helps explain why black holes have enormous entropy, because if our universe is one, it contains an unimaginable amount of information. But there's another twist. Some versions of general relativity, like Einstein-Cartan theory, include a concept called torsion. Torsion accounts for the intrinsic spin of particles, and at extreme densities, it might create a repulsive force, strong enough to prevent singularities from forming in the first place. In this view, instead of collapsing forever into an infinitely small point, a black hole could bounce back, creating a new expanding universe. A big bounce instead of a Big Bang. And the rapid recoil from that bounce, it might be exactly what set our own universe expanding. Not an explosion from nothing, but a rebirth from the heart of a black hole. If that's true, then cosmic creation isn't a one-time event. It's a self-replicating cycle. Black holes birth universes. Some of those universes form black holes. And so the cycle continues. Forever. But there's something else. Some large-scale surveys of the universe show strange alignments. Galaxies distributed and moving in patterns that suggest a preferred direction. This phenomenon is called cosmic anisotropy, and it challenges one of our most basic assumptions, that the universe is isotropic and homogeneous, the same in every direction. But what if it's not? What if the universe does have a preferred axis? And what if that direction is a fingerprint of the way our universe formed? Inside a black hole. What if it's a clue? And then there's one more puzzle. The ancient massive galaxies we keep finding. Galaxies that shouldn't exist so soon after the Big Bang. Galaxies that are too bright, too developed, and too complex. They don't fit our current models, but maybe they belong to a model we haven't yet dared to fully embrace. But as mind-blowing as the universe inside a black hole idea sounds, there might be a simpler explanation. Maybe we're just wrong. Some scientists suggest that the unexpected rotation patterns could stem from errors in earlier measurements. In particular, we might have miscalculated something fundamental, like the rotation speed of our own galaxy, the Milky Way. If that's the case, the mystery isn't cosmic. It's human. But either way, whether it's a flaw in our data or a clue to something bigger, one thing is clear. The universe is far stranger, far more mysterious than we ever imagined. And this discovery, these uneven galactic spins, might be the beginning of a new chapter in how we understand the cosmos. A chapter where the universe is not just a place we live in, but a puzzle we're only beginning to solve. What do you think? Could our universe really be hiding inside a black hole? Or is this just another misreading of the stars? Let me know in the comments. And if you want more videos like this, make sure to subscribe to SpaceFlow.